All right, well, I can go ahead and start. So great to see people here. Thanks for coming. In case you're wondering which one is me, I'm Michael Burand. I'm not Margie. So I am an instructor here at OSU. I've been here since 2012. Margie is another instructor in the Department of Chemistry at OSU. She's been here for a lot longer than since 2012. But anyway, and she can't be here because she's actually teaching the class for which I'm going to be talking about. It's going on right now. So anyway, there's two parts of this talk. If I look at it in a broad sense, I can talk a little bit about using technology in the flipped classroom, which is the main point. But also, I've put in some slides about using it in using technology in our laboratories. So I'm also the instructor for the laboratories, for all the chemistry laboratories. And for both these things, all the technology we use, our LMS, all these other things, have become critical to what we do. We really couldn't do it anymore without that. So it's becoming more and more important. By the way, question-wise, if you get questions, I'm not, jump in with them anytime. Theo tells me I can throw this box at you, and you can ask your question because it's streaming, so you need to have a microphone. So if you fall asleep or have a question, I will throw the box at you. And again, if there's things we want to discuss more than others, I'm happy to be kind of organic with the talk, so just let me know. Anyway, so this whole flipped classroom idea, I can talk a little bit more about what that really means in a second, but I'll give you some background with a few quotes. These are direct quotes from a survey with students. So here, I was a little weary about the hybrid course, but found it to be exceptional. The group work with all the TAs and professors' help was awesome and effective. Well, that's great. I promise I didn't actually write that one. That was a real student quote. Another one, really enjoyed the course, able to learn so much more. I received my first A on a chemistry test, yay. And I think the key there is the person thinks they learned a lot more because of the format, which was really exciting. And then there were other ones. This course basically taught me to never take a hybrid course ever again. Never had such little understanding. Not because of the instructors. I think that was a person trying to be kind of nice, saying it wasn't really the instructor's fault, just the course was so terrible, though, I didn't learn anything. And then my personal favorite, this course has caused me mental, physical, and emotional harm. I don't think I physically harmed anyone, but this person seemed to think so. So clearly there was a range of opinions on it. But I'll walk you through what we did. Again, this is a technology conference, so how we incorporated technology, I'm an instructor, so I rely on a whole plethora of people here to help with that part. So as far as technical questions, I won't probably be a lot of help, but I can direct you towards people who will. But I can tell you about my end of it, kind of the user end. So, okay. What's the background for doing this? Why were we motivated to do it? So what we found, and even before I guess I talk about this a little bit, there's one point up there about research. But what studies have really shown is that with what we call a flipped classroom, at OSU they call it a hybrid course, it's really set up such that, for those of you that aren't familiar with the term, it's really set up such that students are doing what would normally happen in a lecture on their own time. So normally the traditional model is students come in, they sit very quietly, very politely like all of you are. They maybe take notes, they maybe pay attention, they maybe don't. And then they go home, work on problems, maybe on their own, assign problems and do homework on their own, that kind of thing. A flipped classroom, again, just to clarify for everybody so you're comfortable with the term, a flipped classroom really means that kind of static part where they're just sitting there taking in the information, that happens at home. So, or wherever, but it doesn't happen in the classroom. So there's assigned videos. I'll talk more about those that they have to watch, that kind of thing. Students go through. Then when they get to class, that's when they do the problems. So they're working in groups, they're working on problems, they're thinking about it really actively. It doesn't really look like a normal classroom. Instead, it's a room with all these people working on problems. It's noisy, there's lots of talking, and you have instructors and TAs all wandering around, helping guide people by not really answering their questions, but trying to get leading questions, getting them to get to the right answer eventually. So it's very much an active learning technique, and that's where that term comes from, flip. So in other words, again, the lecture part happens at home, and the homework part essentially happens in the classroom instead of vice versa. So how did it arise here? Well, again, my colleague Margie Haak could talk more about this because she did all the hard work on setting this up. And I said, I started at OSU in 2012, so in about 2013, she said, the fall of 2013, Margie came to me and said, hey, I've done all the hard work to set up this course. It's going to be great. Do you want to have in on it? You don't really need to do anything. Just be there and reap the benefits. I said, sure. So the biggest motivation, and I was speaking about this at lunch with a few people, but was actually getting the physical space to do this. Because if you imagine all these chairs in here right now are glued to the floor. I said, okay, I want you to work in groups of 3 or 4 and talk about problems, be real interactive. It'd be hard to do. I mean, if you think about a traditional lecture room, that's oftentimes what they look like, or worse. It's maybe a big tiered seating thing with all these rows of fixed chairs. It'd be like being at a ballpark or something, trying to turn around and talk to people. It's very difficult. So the Linus Pauling Science Center, and this is where I just came from. It's about a 10-minute walk if you want to check it out at some point. We have a nice classroom in there where it has what's listed here as group seating options. Just meaning that the chairs are kind of in rows so that somebody's talking up front, but they also swivel. So it'd be like if this row here swiveled and you could talk to all the people behind you. So it was designed that way to be conducive to group work, which is great. Research, I hope you'll take my word for it. I didn't really want to spend a lot of time in the talk going through the research, but it really does show 2 things. It shows that students that are struggling, weaker students, it says here, benefit a lot more from that kind of active learning in a flipped classroom. Students that are doing well, guess what? They do well no matter what. They still do well either way. So, when I saw that quote, somebody saying, this isn't conducive to my learning style, I don't know how to interpret that, but I have a feeling that person wasn't quite interacting the way we were hoping they would. But anyway, and there's just a note here as well that Margie Haak ran kind of a test version of these classes where she just took 1 day a week and ran kind of a flipped format with it and had a lot of success. So, okay. I want to, I guess, clarify a little bit the difference between a hybrid or, again, flipped. You can think of those terms interchangeably. Classroom versus just a traditional classroom. And I'll use our chemistry as an example. So for the hybrid course, we'd meet, it was 2 times a week. And the real key here was the long class periods. They're 80 minutes. And now it says this, oops, sorry. Now it says subsequent terms, and that's where we're at now. Both are 80 minutes. Because we found that that was really, really important in order to have people be able to work in groups effectively and have time to work on problems, get help from instructors, from TAs, and then have 20 or so minutes at the end to kind of decompress and do a wrap-up and go through some of these problems together. If you tried to cram that into a 50-minute lecture period, it just wasn't long enough. So in order for hybrid to be successful, it was really important that we did that. No recitations, so in other words, these were our only meetings. Attendance required. That was, that's part of the whole thing, is that if a student is not coming to class in a lecture, well, most lectures, oftentimes they don't even notice. At least a lot of times they didn't notice when I didn't go to class. But in this case, it's really important because it's an active part of the learning. So we want students there, we want them engaged, we want them really involved. So it's a crucial piece. So we do take attendance and they get points for. We don't call it attendance, we call it participation. Because some students think that I show up and my physical body is there, that's good enough. Well, we prefer a little more. A note here, 2 to 5 videos per class period. So that would be about, to give you an idea of the average load, so these are 10 to 15-minute videos. Students watch somewhere between 2 and 5 of them typically before they come to class. So they're assigned these videos to watch on their own time. And again, what are the videos? Well, they're the same topics that would be happening in a regular lecture. So some just demographics on the course composition. Under 200 students, but not a whole lot under 200 students. In our regular traditional courses, it's 1 instructor. And I've done that where it's me, I stand up in front of about 200 people and I talk and talk. Occasionally somebody is brave enough to ask a question. But it's a little more static. With this, as I described, we're going around, we're helping these students, we're trying to be really interactive. If you think about that, it's not feasible with 1 instructor. I've talked to students, and I talked to one, I remember this really well. He said, I had a hybrid course before, and it was terrible. I said, well, tell me about it. Why? And we got talking. He said, yeah, there's about 200 students. He said, and 1 instructor. Trying to run frantically to all these groups of 3 or 4 with 200 students and help them out. I said, well, of course it was terrible. That sounds awful. So we have a minimum of 4 TAs, 2 instructors. That's a minimum of 6 people, and sometimes we have more. This term, as a matter of fact, we have learning assistants. We have some other support in there as well. So that was another big piece. So the room setup was crucial. A number of people in there to help was really important as well. Okay, and then both of these courses, whether it was traditional, which still is taught at OSU, both formats are now being done. Both have online homework through Mastering Chemistry, that's Pearson's program. And then the laboratories now for both are guided inquiry, which is something I came up, well, I didn't come up with it, I would love to have invented it, but I brought it to OSU and incorporated that. So I'll spend a little time talking about that as well. But anyway, so the videos. This is probably one of the more pertinent things for this particular audience. It was really important that they not be the equivalent of somebody setting up a video camera in the back of a lecture hall, turning it on for the whole lecture, and then leaving. If that doesn't sound terrible, it probably means you've never had to sit through a video of somebody giving a lecture for an hour, right? So it would be pretty awful. So what was really neat is that, right off the bat, we said we don't want to do that. We want to be really clear. Fortunately, we had some really good support on campus to say, hey, look, we want a situation where we can make these videos. They should be topical, so we'll have a video about resonance structure, one about rate laws maybe, one about geometry, something like that. All these chemistry topics, about 15 minutes is what our goal was. Some of the research out there says it should be shorter, should be 10 minutes. I don't know, I can't do it. I can't get through everything I need to get through in that amount of time. So one thing that I still haven't been able to quite convince students of, these are intended to supplement the reading, not supplant it. So I don't know that students are reading any more than they ever really have, but they are pretty good about watching the videos. What's interesting too, and this is the last point up here, and it bears spending a minute just talking about, is that the videos ended up being, when you take all the videos we record and you add up all the time, and then you take all the time we would normally spend in a regular lecture covering all that, the videos were only about 2/3 the amount of time. Now, if you're generous, you might say, well, yeah, but maybe that's because in lecture you're answering questions a lot, you're doing that thing. I'm afraid not. That doesn't make up for that difference. Really what it is when we sit down and make a video, we're so much more efficient because we've kind of practiced what we're going to do. Some of these we did, 7 or 8 takes, and we finally just said, OK, this is good enough. We're going to have to just give up. So I had this notion of going in there and just doing one video for everything. I can do this once, of course. And then it doesn't work that way. So anyway, we found that it was much more efficient, so that was really exciting. So in other words, you take all the time you would have to spend sitting in a regular lecture and instead condense it. It's not even really condensed in the sense that you're lacking anything. It's just condensed in the sense that the filler and the time I spend, I guess, mumbling or doing other things or telling bad jokes. I still tell a couple bad jokes in the videos, but in a much more efficient way. So that was really exciting. And that's one thing we try to get students on board with this and say, hey, here's why we're doing this. You're going to learn more. You may not like it. Nobody's promising that. It may not be your favorite, but you're going to learn more. If you're already a great student, good. You're still going to be a great student. And look, it's going to take you less time. So it's going to be more efficient. So that was neat. Whoops. All right. OK, here's a paragraph I really don't understand. I assume many of you do. So Raul Buriel helped, among a lot of other people, help get this going for us. And I co-authored a paper. I should say book chapter, I guess, in this book. It's called The Flipped Classroom Volume 2 with Margie. And they wanted something in the book chapter about the equipment we use. I said, I have no idea. So I wrote to Raul. I said, Raul, can you send me one sentence, please? I can include as a footnote. And so somewhere in that chapter, if you read it, says, the technically minded reader might be interested to know that we used, and then that whole sentence goes in there. Having said that, we've now changed our setup a little bit. And so I took a picture just very recently of the new camera, and I apologize for the very poor quality. But this gives you an idea. Here's our lab space. And you can see it's a much more, shall I say, instructor-friendly setup. It's very simple to use. It's nice. Basically, grab that boom, point the camera where you want it, hit the record button, go when you're done. You hit stop, and even I, as a humble instructor, can figure out how to do all that. So that's great. So we've already done some recording with this newest setup, and it's been very easy to use, really nice. OK. By the way, worth mentioning too, note that this is set up in our chemistry lab. And so that was important to us. There's plenty of space on campus. We could have gone to another room, or we could have gone to some studio somewhere and done this. But this was really important to have this camera set up in our lab space. I'll talk about how I use it for the laboratory course in a minute, but even for the lecture course, it's nice to have it in there. Sometimes we do chemical demonstrations. It's very easy to take that camera, point it at a couple beakers or whatever we're going to use, and do that demonstration. Whereas getting permission to take chemicals to other buildings and bring them in and do demonstrations there, they tend to frown on that. So it made a lot more sense to have this set up right in the chemistry lab. There's also a more subtle reason to do that, which is I think it's important for students to see a space they're familiar with and ideally people they're familiar with. So we could certainly, there are many, many, many presenters of chemistry far better than I am that have YouTube videos or something. I can just say, hey, watch these videos. They're from a university you've maybe never heard of. They're in some studio with a professor you don't know. That's fine, but I think it's an important part of this to have students be able to see someone, the actual instructor for the course, in the space they use, and kind of relate all that together. I think it makes it a little more accessible that way. OK. As far as the classroom setup, I've already discussed this a little bit, so I won't spend much time. But here you can see a photograph. This is Linus Pauling Science Center, 125. And these two people, one looks like he's in the military, and the other person, they've actually swiveled their chairs around, even though the front of the classroom is behind them, so they can work in a group. And so that's a group of 4 students working away, doing problems during what would normally be the lecture time. OK. So typical class period, again, just to clarify how this really works, because I think this will help understand how we use the technology and what our needs are. So students arrive, and we still use just the printed paper. A group member comes and picks up other problem sets for that day. So then, if there's announcements, only about 5 minutes. And this is a key part, that this is why that 80-minute class period is so nice, because students then work on the problems with their group for about 45 minutes. A good block of time to really tackle some of these problems. And we come around and we spend a lot of time with TA training. Because if these people over here are a group and I come over and they say, we're struggling, I say, oh, the answer is 7. And I turn around and walk away. I haven't helped them at all. They think I have. I've told them the answer. So the best thing to do is we try to get our TAs to ask more questions. Say, well, what are you doing so far? What ideas do you have? OK, well, you didn't get 7. You got something else. Why is that? That can be really helpful. But training TAs to not really give out answers, despite the fact they're so proud they know how to do this and they're really excited to teach, that takes a bit of effort. But that's our goal. So then the last maybe 25 minutes, 20 to 25 minutes, we reconvene as a whole group. So we say, OK, hey, everybody, pause there. And we go through some of the problems together. So they get a little bit of a wrap-up to it. OK, and then at the end of class, they do turn in those group worksheets. That's a part of what we use to gauge their participation, attendance, make sure they get points for that. Because it is important they go and they participate. Then it's also important to us not to present the solutions right away. And we've changed this a little bit. We were in our, I guess, 4th or 5th year of this by now. But the first year, we just posted the solutions online the next day. So students were working on that worksheet. We never quite gave out answers, or certainly not answers to all the problems on the worksheet. Obviously, we want students to be able to see the solutions eventually so they can study from them. But our goal is that students spend a little bit of time thinking about this on their own first. So if there's a problem in class you couldn't quite get, it's much more beneficial for you to take it home and work on it a little bit more and really keep trying to solve that problem than just look at the answer and go, oh, yeah, I suppose that makes sense. I could have done that. So the first year, we just did it the next day. And students were happy, but we weren't convinced they were getting that piece where they really had to think and reflect on their own and try to solve this problem. Second year, we did it at the end of the week. We thought, OK, well, we'll just wait a week. Well, that kind of frustrated students. And by the time the week was up, it wasn't as helpful, maybe. So now what we do is we give the numerical answers the day of. And then by the end of the week, so about a week's time, we'll post the worked out solutions. And in other words, just to clarify that, so it might say problem 1 has, asks you how many joules of energy are used up by this chemical process. And so the first just answers might just say 7 joules, and that's it. I won't tell you how to get there, but if you did the problem, you're able to get the answer, you'll be able to verify it was right. Then about a week later, you'll see, or the end of the week, you'll see a full solution that says, here's the answer is 7 joules, and here's how you do the math to get to that answer. Right? OK. So here's an example of a problem. This is one we like to give it on the first day. It's got nothing to do with chemistry. It can be solved. But if you read through it, it doesn't seem like it can be solved, and it says, and students, this drives them nuts. They say, well, what has strawberry pudding got to do with this thing? It's a terrible problem. We have about 4 problems like this that students get. I mean, they tend to get really frustrated. They say, well, you can't solve it. Oh, sure you can. It can be done. If you talk to me later, I'll tell you how. It took me quite a while. I had to get a little help, but you can solve this problem. But the idea is that we're not giving out simple problems in class. We want that class time to be used to really challenge students. If we give a problem that's easy enough that a group of 4 can all just sit there and just do it by themselves, we haven't really met the goal at all. Right? Because I want to say, wow, do you have any, I'm stuck. Do you have any idea where to start this? He said, well, I don't know either. And we all kind of talk as a group, and we start bouncing ideas off each other. That's the goal we're trying to get to with student interaction. So a couple of chemistry ones would be things like this. And I apologize, the font's getting ever smaller. But you can see, the point is you can see these aren't real trivial questions. It's not, 14.8 grams of carbon, how many moles is that? Usually they take a little more. So this one, imagine a universe where the quantum number m sub s can have values of 1/2, 0, and -1/2. If you're not up real recently on spin quantum numbers, in our universe it only has +1/2 and -1/2. So in this imaginary universe, it now has 3 values. So draw out the first 4 periods of the periodic table, what it would look like if all the other quantum rules were still in effect. That's not a simple question. At least it's not intended to be, and if you think it's a simple question, that's great. You know a lot about chemistry and physics. But again, an important thing to mention here, and there's another one I don't need to necessarily spend a lot of time going through with you, but about objects cooling and heating, that kind of thing. But the idea really is that students are challenged by these. They're not graded on accuracy on this at all. These problem sets are graded. We collect them to see if they were participating, see if they were making an effort. They're not graded. So in fact, our usual intent is that students don't even get to finish the worksheet. Because if 20 minutes into that 45-minute time where they're working, students say, OK, I'm done. Our whole group got to the end, got all the right answers. It means we really weren't challenging them up to their potential. Anyway, OK, so enough of that for now. And then just a couple minutes to tell you a little bit about how we present these results to the class. Because I said there was this 25 minutes or so, 20 to 25 minutes at the end where we do a wrap-up. We've tried all kinds of things. I'm not convinced we've settled on one that's the ultimate best of all, but I'll tell you a couple of them. And one of my favorites involves some neat technology, I think. So here's the very low-tech version. We draw numbers literally written on poker chips. And those numbers, each group has a number. And so we say, hey, group 6, guess what? You can come to the front of the class and present your results. Students had mixed feelings about that. They didn't necessarily like to be called up to the front and try to present their answer. So but it did get them the thought that they might have to come down and try to explain, if not the answer to the class, at least how far they got. I guess encouraged them, if that's the most polite word I can think of, to be really, to really work hard on the worksheet as best they could. And it was fine. Oftentimes students would come up and say, well, we didn't get an answer. We say, that's fine. Go ahead and explain to the class, as far as you got and where you got stuck. A lot of people probably got stuck in that same place. So that caused a lot of, I think, student blood pressure and heart rate kind of went up with that one. But if you said, OK, come and explain this alternate universe where you have these 3 quantum numbers, OK. But that was one option. Another option, instructors present. That's probably the most boring, but it works. One problem is that students, they can be great students, but not very good teachers. So even sometimes if they would get the right answer to a problem, they'd come up to the front and they'd say, they wouldn't really be articulate about it, so other students watching didn't necessarily get the full benefit of it. So of course, one thing is we could just stand up there as instructors and just say, OK, well, here's the answer. Here's how you should have done the problem. And they can ask us some questions. This is the one we probably do the most. But that pressure that we like to put on students to say, hey, you should really work on this worksheet, right? We really want you to make an effort. That takes away a lot of that. We don't like that. We want them not to be uncomfortable, but certainly to feel motivated, right? The last option, I think, is one of the most interesting. And we've done this on and off. We don't do it consistently, but we may be moving to that, is using learning catalytics. Is anybody familiar with learning catalytics? OK, not many. A little bit. Or do you just have an itch? OK, so anyway, what it is, who's here has heard of clickers in the classroom? OK, excellent. Most people. So clicker is just a small little device where you, as a student, can, I think there's only like a handful of buttons. It looks like a really old-fashioned remote control, where you can submit answers wirelessly, essentially. So Learning Catalytics is just a program that allows you to use your smartphone as a clicker. This is something all students have on them all the time anyway. So it's kind of nice. They don't need to buy anything. This is Pearson, I believe, is the one who's running Learning Catalytics now, but is that company. But so students, the other thing that's nice about this, they oftentimes have their smartphones out anyway doing other things. So it sure is nice to if they're going to use a smartphone, to have it be something for class, right? So again, it's just, you can think of it just, if you're familiar with clickers, most of you said I've heard of that. It's just the smartphone version. So they don't need anything to buy. They already have it. When they buy the textbook, they get access to Learning Catalytics already, so we're in good shape there. So what kind of things can you get from it? Well, it's kind of nice, because here's an example of a question where, again, this would be our wrap-up at the end, and we would say, OK, here's one of the problems, and tell me where in this plot, this phase diagram, tell me where the liquid phase is. And this question, they just had to look at the diagram. They didn't see the colored dots. They just saw the black and white photo. And they had to vote where they thought which region, the one on the left, the kind of the upper one or the bottom part, was the liquid phase, right? And nobody picked where it says solid for probably obvious reasons. That's good. But what we see is this result. And we can see, oh, look, most of the students did get it right. It's all the little green circles. A few thought it was actually, that's the gas phase, by the way. You are, anybody not familiar with brushed up on phase diagrams. But most students got it right. That's helpful to know. This is really nice for feedback for us, because we can say, hey, we assigned this problem. We're doing essentially an instantaneous survey to see how many of you understood it, right? And then what we can do is we can either just go through the answer, or we can say, wow, most of you didn't quite seem to understand this. So let me give you a couple more hints, and I'm going to have you work on it again. And we can redeploy the question and get the results back. So that can be really nice. What you're seeing over here is a map of, this is actually all the seating in LPSC 125. This maybe isn't the best example, because you can tell not a lot of people voted, or there wasn't a lot of people logged in to Learning Catalytics. But all the little green squares are people that voted and got the answer right. Red squares are people that voted and didn't get it right. And then the gray squares are just people that are there but didn't vote. So it's really nice for us, because we can say maybe, this is part of the instructor view of this program. Students don't see this, but we can say, oh, this group up in the upper right corner, they seem to have a great understanding. I guess I don't need to go talk to that group. That group in the upper left, boy, there's only 2 people, and only one of them voted, and that person got it wrong. So maybe I should send a TA up there, stop and see those people. So this can be really, really nice. OK, a few more things to go through. And I do want to leave time for questions. I hope there are some. I hope I've been sufficiently vague to leave room for questions, but we'll see. OK, exam scores. I don't think I need to take you through all these numbers. Here's some from back in 2014-15. We do have more up-to-date data. But essentially it showed, and the more recent data especially show, that exam scores at worst, in our worst exam of the worst term we've ever had teaching the flipped classroom, are about the same as they were in traditional classrooms. So it's not making anybody's grades go down, right? What we do see, though, most terms, especially more recently, even since these data in this slide, is that their scores actually go up a fair amount. And it's gotten to the point where we tell students, you know, on average, you're going to be about a letter grade higher in this course than you would be if it was a traditional lecture with me standing here talking and you taking notes. One thing I think is really important to do is get students on board to why we're doing this. Because if they just come in and say, boy, Burand and Haak, they teach in this weird way. I'm supposed to watch these videos and then sit here and it's not what college is supposed to be. I'm supposed to sit here. You're supposed to be somebody smart telling me what to do. I'll write it down. It comes to the test. I'll look over my notes and I'll give it back to you, right? So that they're out of their comfort zone quite a bit, but I think in a good way. So, OK. I did want to take just a few minutes, and then I'll wrap up kind of in a big picture. I've been talking about the laboratories. I'm particularly proud of this. When I interviewed out here at OSU, I said, and this is one of the big reasons we were talking beforehand about, why did I come here? Why did I go to OSU? Well, this is one of the biggest reasons, is that I was out here doing the interview, and I said, I think a guided inquiry approach to laboratory would be huge here. I think it would be great. I would love to work here and put that in place. And faculty members, a few said, wow, you really think that'll work here? And I said, yep, it's working other places with as large enrollments as we have. I think it can work here too. And they said, great, go for it. You're hired. So that was exciting that they had confidence in me to do that. And here's a couple of quotes. I don't need to really read them to you, but these are TAs that really felt that students were learning a lot more from the guided inquiry laboratory approach. I hope I've already shown how much our hybrid course relies on technology. I want to take a couple minutes to show you how we use it in the laboratory. Even more so than we do probably or just as much in the hybrid course. So again, some demographics for this, about 1,300 students. So 54-ish lab sections per week. That's a lot. So I'm the instructor of record for all 1,300 students. Do I actually physically go in there? I don't think it'd even be possible. So I have about 30 TAs. We have a great issue room staff. We have a laboratory coordinator. That's me. A head TA. And then I think I was particularly proud of enforcing this. So we have one mandatory TA meeting per week where we all come together with all these moving pieces and try to make sure we're at least somewhat on the same page. But logistically, I mean, we're at a big institution. So every week, 1,300 students come in and do a lab. So I've spent a little time with you defining what a flipped classroom is. And I'll ask you to bear with me for one more definition on a guided inquiry laboratory. So it's almost easier to describe what a guided inquiry laboratory is by describing what it is not. And I've tried to set that up here. So traditional laboratory format, you have what was essentially, for all practical purposes, a recipe. Students walk in, it says, step 1, measure out 20 milliliters. OK, go over, get the beaker, measure it out. Step 2, dump in the blue stuff. OK, step 3, stir. Has anybody here had a lab like that? OK, some people don't want to admit it. But yeah, most people kind of going, yeah, OK. I certainly did. OK, that's fine. And students they'd complete the project. They would obtain really good results, and they'd get a good grade. But then they would have no idea what they did or why they did it. Right? And maybe that's some of us in here, too. It was me as well a lot of times. Right? You mixed the blue stuff, and it precipitated out some other stuff. Why'd you do that? Well, I don't know. You told me to. Well, what have you learned? Well, nothing. Oh, well, whose fault is that? Well, it's kind of hard to blame the student. They did what we told them. Right? So instead, we've moved to a guided inquiry laboratory program where, well, the concerns pop up right away, of course. But a guided inquiry, before I get into all these concerns, a guided inquiry program really means that students are instead given a goal. Your goal is to make this compound or analyze titrate this solution and tell me what the molarity of the unknown acid is. And that's it. There's no instructions. There's background information. That's where the technology part comes in. There's certainly help. It's not inquiry. It's guided inquiry. So you have a TA there who's much more of a coach kind of helping out. But there's no step-by-step list of instructions, things you have to do. Right? It's just, hey, here's a goal. Here's all the tools. Here's some support. You figure out how to get there. OK. So right away, and this does take me back to those moments when I had that interview out here and people asked me these questions. They said, oh, my gosh, this won't work, and here's why. Academics sometimes are very good at telling you why something won't work. And so they said, well, if one group member is not paying attention, because we're going to do this in groups, just like we do in the flipped classroom. And so the 3 of us are in a group, and I'm not doing anything. I'm just kind of hanging on with all your help. Isn't that a problem? Not really, because we have some scores that are based on the group work, assignments that are submitted together, the 3 of us as a group, for example, some scores that are individual. And so maybe I'm kind of piggybacking on your efforts with the group. I don't know, I'm picking on you, but on your efforts with the group things. But when it comes time to turn in my own laboratory report, and I haven't been paying attention or doing anything, well, that might not go so well. So some other things. So because there's no step-by-step set of instructions, students actually make their own plan. The only time I can guarantee those students are going to be together able to make their own plan would be during lab. So we have 3-hour laboratory periods. We say the last 45 minutes to maybe an hour are actually designed so that students can stop doing chemistry, get together, and work on the plan for the next week. So they say, OK, boy, our goal for next week is to figure out the molarity of this unknown acid. How are we going to do that? OK, let's come up and create a plan. So the big question is, wow, is it really worth giving up 1/3 of your lab time to do that? Yes, I think so. I'd rather have you spend 2 hours where you're really learning a lot, getting a lot out of it, and then a good hour of planning than it would 3 hours where you're just kind of going through the motions, not knowing what's going on. So won't students rise up in some sort of revolt? Yes, a little one, often. It's usually fall term. I get some people coming to my office saying, you're not giving us instructions. I say, yeah. So, but I've had chemistry lab before, and we're supposed to get instructions what to do, and I'm going to do it. And the part they don't say that they mean is, I'm going to do it, and then you're going to tell me, you're going to say, OK, good job doing it, and then you're going to give me an A. But you didn't tell me what to do. I'm not a chemist. How am I supposed to know how to do this? And I explain this in a few different ways. I say, well, look, first of all, we're trying to prepare you for real life. If you go do research in a real-life research lab, there's not somebody saying, here's a step-by-step list of instructions, especially not if you're going in at a higher level. You're going to be a college graduate. More often it says, here's our goal, right? Something all of us are familiar with. Let's figure out a way to get there. Okay, so if we want to really mimic real life and prepare students for real life, this would be a much better way to do it. The other thing that, and my last bullet point there, students, they're really relieved typically to know that they're not graded on the results. So if we go back to that example, I keep going, my recipe example in this lab that many of us in here have had when you think back to your chemistry days of, okay, step 1, do this, step 2, do this, and you get down and you're supposed to get all the way to step 10, but you only got to step 9. Well, okay, you get a B. Well, you only got to step 8. Okay, I guess you get a C, right? Because it was very results driven. This way, it's process driven, right? So I don't care if this is a group of people right here and they're all working really hard and they tried an idea, it didn't work out, they didn't get any results at all. They didn't even make the compound they were supposed to, but they know what went wrong. If they had more time in lab, which they don't, they know what they could do differently, how to fix it, how to make it really work well. Great, that can be an A. You can get 100% submitting a summary or a lab report explaining that. So that's really the idea with that. Again, I promised I'd leave a little time for questions, so I'll go a little quicker here. TA training, I think I talked about this before a little bit, but the same thing applies to lab. It's a lot more fun. There's a lot of research saying students learn a lot more from a guided inquiry lab, but there's not much that talks about TAs. And they're really important to us, of course, and we want to make sure we're doing the best for them we can. And in the old way of teaching, TAs were really just tech support, right? You'd say, hey, this thing was supposed to turn blue and it didn't. The TA would go, okay, fine, show me what you added. Yeah, you were supposed to add this other one. I mean, really, something went wrong, you went and saw your TA. At least I did when I had chemistry or physics lab. Everything was going right, fine. This way, TAs have a much more active role. They're constantly coming around. They're saying, hey, how's it going? What's your plan? Students say, well, we're going to take 40 liters of acid and dump it in. And you go, okay, well, yeah, well, tell me why you want to do that. Sure, that's a good idea. Maybe we should think of something else. It's a lot more fun for them. They're more of a coach. Okay, I also try to sell it to TAs by saying, hey, many, if not all of you are going to go on to get your PhD in chemistry. And so you'll probably be in some career, even if it's in an industry where you're in charge of managing people, working towards a goal. So your TAing is going to help you. Okay, we do a lot of TA training. Details on that I don't think I need to go through. Forgive me for going quickly through this, but I'd rather talk about it. And then so now getting back to, and by the way, students in the flipped classroom also take the guided inquiry laboratory. In case you didn't catch that on the earlier slides, that's how these things are all related. Getting back to things that we've done for both now the laboratory and the course. So we created a head TA position. As I said, there's a lot of moving pieces. You can imagine with 1,200 to 1,300 students a week. Keeping everything organized has been really a challenge. So we got approval from the department to have a head TA, which is just we take one of our TAs particularly good, a good fit. We put that person in place of kind of being somewhat in charge, and that's really nice. We also have a laboratory practical exam. That's just something I've added. I don't think I need to talk about it a lot in the interest of time. So I think I'll maybe finish up and skip my last few slides at the very end because I've rambled on enough about that topic. But I do want to talk about this because here's where the technology comes in. It used to be, at least when I was in labs, you'd go to the lab, you'd have a lab notebook you had to either buy from the bookstore. If you're lucky, they'd give it to you. It was a paper notebook. You had another paper notebook where you'd write your answers in, and that would be that. Now, almost everything is done electronically. The only sheets of paper students handle is the actual lab notebook itself, which is still true in many, if not most, industry settings and that kind of thing. A lot of people are moving to electronic notebooks. We haven't done that yet. But so in addition to the videos I talked about for the flipped classroom, we also do it for laboratory. So students have a little introductory video, and there's me possibly wearing the same tie. I don't think so. There's me introducing a laboratory, about a 10-minute video, same thing, telling students, hey, this next week you're going to do this lab. I'm, of course, not going to tell you how to do it step by step, but here's some hints and here's some background information. So you're not feeling like, oh my gosh, they're just telling me to do this lab and I have no idea. Really nice technology-wise because we can flip over to the document camera, something like that. And the picture's a little fuzzy, but that's my hands kind of working out an equation, giving them a hint on how to do this. So typically we start showing us, introducing the topic, talking a little bit, and then doing something like some sample calculations. So Our learning management system is Canvas. We've developed this a lot, and it's been fantastic. You can imagine with about 30 to 40 TAs, we really need to have consistency with grading. I have a lot of those awkward conversations where students come to my office and say, hey, my friend's in this other lab section. That TA gave an A, and I got a C. And I go, OK, so where do we start this? So we do everything we can to try to mitigate that. And this, I apologize, is kind of an eye chart. I know you can't see it very well, but this is a rubric for one of their assignments in Canvas. And it's very nice because students can see this, so it's totally transparent to students. Hey, if you do these things, you will get this score. So here's 3 points for this, 4 points for that, 3 points for that. That makes 10 if you get all the points. So students see this. It's very transparent. When TAs go through now, wherever they are, students submit their assignments electronically. Like I said, we've gotten away from paper. One of those last slides, it was 500,000 sheets of paper not printed. Because of this, I think now I'm up over 1 million. I should do another calculation. But so the really nice thing is, so TAs can pull up from any computer they can log onto Canvas from. They can pull this up. They can see the assignment. They can grade it right there. They can actually click these boxes. It will automatically sum up the total of points and put it in the gradebook. So that's great. Then when a student says, hey, my TA gave me an 8. Why did they give me an 8? And before I had to say, well, I don't know. Do you have your assignments? No, I think it's in my room or something. Now students I can say, well, great, let's look. And I'll say, well, yeah, your TA ranked you a 4 in this category, but only a 2 here and only a 2 here. So we can have a conversation, talk about that. That's really nice to have that feedback. OK. So also, just quickly, another slide. Here's some student work that was submitted. And TAs can write comments, which is really nice, too. So here the student had put this equation in there. The TA highlighted it and said, that actually worked. You kind of got lucky, but it's really not the right equation to use. So FYI, next time, make sure you're doing that. So that's helpful. The great thing about this, I can log in from anywhere and pull this up as well and see, not only is the TA doing the TA's job in grading and providing feedback, but I can see, OK, why did the TA take off points? Or what specifically was wrong? What can I do to help the students? So Canvas has been very helpful for us in this respect. Another feature, and I am running short of my time, so I'm going to be real quick here. Turnitin. This is just plagiarism checking. So I was sure to cut off all the names when I copied this, but here's just a sample of laboratory report scores. And Turnitin marks them with a little flag. So the yellow one, I can't remember what blue means, but yellow is a little bit more matching text, but not too bad. I think the record I've seen is 99% matching. A student just changed the name, and that was it. So that one, yeah, those conversations get awkward fast. But fortunately, out of 1,300 is a very small percentage we have to deal with this. But this kind of keeps people honest, I think. OK. Some updates for the laboratory part. I would like to, so Raul, who you just saw speaking at lunch, he the other day gave a presentation where he talked about embedding quiz questions right into the videos. And I think that's something I'd like to do because then when students watch, it's a little more motivation for students to watch the video. So halfway through the video they're watching, a question could pop up and say, what chemical is appropriate to use here? And not worth much for points, but enough to get students to see it. Same thing, I'm considering making it so that they can't access the actual lab handout till they watch the video or at least view that thing in Canvas, just to kind of encourage students to be more prepared for lab. Because much like the classroom, a lot of the preparation happens on their own time. So I think I'm going to, in the interest of time, very quickly skip through this. I talked about a lot of this already. These are some other changes. And go to the acknowledgments. Well, I still have time and leave a few minutes for questions if I can. So Rich Carter is our former Department of Chemistry chair. But he was the one who really approved this program. He was very, very on board with both the guided inquiry laboratories, but also the flipped classroom. He put a lot of support behind it. So I would be remiss not to thank him. Mike Lerner is our current Department of Chemistry head. It changed from chair to head for reasons beyond me, but he's our head now, and he continues to support it, which is fantastic. Raul, who I assume pretty much everybody here knows, has been really helpful with all the video end. Don, fantastic with actual physical setup. And then of the equipment and helping us learn how to use that. And then Tasha Biesinger, another person who's been really amazing for Canvas support. So there's no way I could have figured out how to do any of this without all their help. So that's been really fantastic. A list, I won't read through all the names, but a list of our TAs that have been really instrumental in helping us do it in the classroom. So that's all I have. Thanks for listening. Does anyone want anything? Anybody? OK, oh, the farthest person back. OK. There we go.
You talked a lot about how technology helped you get like feedback to kind of hone your practice in the labs and in the lectures. I'm curious if you looked at any of the analytics around the videos that you create and what, if any, learnings or changes you made based on that.
Right, it's a great question. No. We, a little bit, from like a very non-technical instructor side. So one thing we saw with the, and I didn't talk about this, it's a great question, I didn't talk about this. With the flipped classroom, we used to say, please watch the videos and then come to class. Guess what percentage watched the videos? It wasn't 0, but it was far from 100, I can tell you that. And we would say, hey, look, if you're not watching these videos, you need to understand that's akin to skipping class. Right? Like, because remember, this is a shortened amount of time you're spending in class, just working on problems. You're not watching these videos. That's just like not going to class. They go, yeah, a lot of times they still wouldn't do it. So we did some very informal, very non-statistical analysis that way and found, hey, what are we doing? So now we have a quiz, a pre-class quiz that they have to take. But here's the key. To unlock that quiz, you have to watch the videos. Well, I take that back. You have to open the videos, right? So stuff. I can't. And even if even if there was a way to force them to sit there for the whole time, or force them to have the duration of the video play, I couldn't say they weren't there. But that's helped a lot. So and that's where this idea, and you keyed into it quite well, came from with same thing for laboratory. So laboratory, we're kind of back at that thing of, hey, please watch this. It'll help you. And by a term or two later, they figured it out. But I'd really like to get that from the get-go. So I think having a couple of motivating questions, right, like a quiz question or something unlockable such that you get a couple points for doing it, I think that could really help. So, yeah. Anything else? I don't. OK, you got to use the.
So you talked a lot about like student expectations of coming into the course, but you also mentioned a number of institutional players kind of at OSU. What are your expectations as an instructor of who's trying to innovate their pedagogy in the classroom of the institution or the administrative support when either using the tools or regarding pedagogy specifically? Right.
Well, there's my expectations, and there's and hopes and dreams, and there's what might actually happen. And I'm happy to say those are pretty closely aligned. So I have to give credit once again to Margie Haak, who's really a co-author on this talk. She said, hey, I want to do this. I want to do this flipped classroom. All this research shows this is great. And the department said, great, go for it. But what kind of support we need is a lot of what I've been talking about, right? So there's the physical layout of the room. Right? We have to have seating where students can actually do this. The laboratory is a laboratory, so that one's fine. But for the flipped classroom in particular. But there's also, yeah, you're right. And that's one thing I think I really have to give OSU a lot of credit for, is being willing to do this. And at the end of the day, I work with a bunch of scientists. Right? So if I say, hey, we have this idea for a flipped classroom or this idea for a guided inquiry lab, I think it'll probably work. They'll say, I don't know, OK, maybe. But if I can go in there and say, hey, here's literature data supporting that this will work if we do it, and our students will, the outcomes will be better, they'll learn more. So, are you on board? They're like, sure. So I don't know if I'm answering your question quite right, but is that what you meant, or what?
Yeah, and I guess what I'm looking for is what, at the institutional level, technology support, is there anything they're doing that particularly makes you successful in this, or are there things you expect from them in your role? And I was just, again,
yeah, OK, yeah. I mean, and I still don't know if I'm going to answer this quite right. So, but tell me if not. But basically, what I've come to expect, and I'm spoiled, is that I can pick up the phone and say, hey, this isn't working. Can you fix it? And somebody will. But it goes beyond that. I can now say, I sometimes don't even know what questions to ask. And the best example is when I talked about Raul saying, hey, you can now put quiz questions right embedded into a Canvas video. So one thing that, I don't know if I've come to expect this, but I've certainly made use of it, and it's really helpful, is having interactions where I'll hear about a presentation on some Canvas thing or a Kaltura thing or a video thing where they'll say, hey, we're giving a presentation on this, things you can do with it. I think OSU is particularly good about providing that kind of opportunity, because I don't even necessarily know what questions to ask. Sure. So I guess, again, they might be somewhat spoiled, but my expectations have really have risen to that level of not only, hey, if there's an issue, can you fix it? So like, hey, this camera, I can't get it to work. Somebody's there in minutes typically, right, which is great. But it goes beyond that to, hey, this camera system is great, and the interface and the videos we embed here, but is there a different way I can do this? Is there other ideas I haven't yet thought of? And so that can be really helpful. Cool. Is that a little better? OK,
yeah,
I knew we'd get there. So, well, I want to be respectful of time, but I think we can do No, we can do it now. Go ahead. Nobody's
Quick
given me the hook
question.
yet. I'm okay.
To get back to your second slide, you kind of started out with the student feedback, and you showed.
Oh
it-
yeah, I really want to see it again, but
Well,
I
you showed it in like a balanced way, so you had like 2 positive
Right.
and 2 negative. But is that really representative of like?
that is
Or
a
is
great
it-
question.
yeah.
So in that book chapter we wrote,
Yeah.
we plotted some data on this, and so it is actually representative. So what's interesting is if you we took the same cohort of students and we said, okay, which would you prefer to take, a traditional lecture or this hybrid format? And it is about 50-50, right? We find. And interesting, it's not like kind of a wishy-washy 50-50. It's usually people have pretty strong opinions. There's a few people say, I don't know, either one, fine. But typically that's more representative. You see people, wow, I really don't like this, or I really do like it. But what was fascinating is, and when we looked at the data for that group, that same group, we found that they were doing better, whether they liked it or not. So my analogy is always, do you want to go running at 6 in the morning? No. Some people do. Good for you. I'm not one of them. But do I begrudgingly admit that, yeah, it's better for me if I get up and do that? Absolutely. So I think there's a little bit of that at play. What was fascinating to me, though, is we asked that same group, do you feel like you're learning more? Right? I'm not looking at your exam scores, but I really want to just, do you feel like you're learning more? In that same group where about half and half, and I think a slight majority, like 51 or 2% said they'd prefer traditional. Actually, we had a majority, albeit slight, answering the opposite, saying, yeah, I actually do think I'm learning more. So even a portion of those people that said, I'd much rather have a traditional, they still admitted they were learning more.
They just want to walk in and have you dump the information into their
Yeah,
brains.
exactly, sure.
And
And
they're
that's
just
what
not
they've
used
come to
it.
expect, right?
Yeah.
So when you think of college, you think of some person, maybe a bow tie, but probably a big beard or that, kind of thing, and it's the sage up there, giving all this information. You sit there half awake taking notes. So they're very uncomfortable when they come in and see that. But they're getting better. And especially in subsequent terms, they just go, oh yeah, this is just how we do it. But at OSU here, we still offer both a traditional format and a hybrid format, so students can kind of get mixed up on which to expect. Well, I think we're done. Thank you again, everybody.
Thanks. That's why it's always with a grain of salt.
Yep. Exactly.